Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back, team, and let's continue the today session with some of the networking concepts. Okay, so I think since we got like almost 3 days of gap, uh, uh, to have a quick recap, what is that we have discussed so far is we have touched base with some of the Linux basics and the AWS basics, and that's where we have understood how to create a simple easy to instance in the AWS cloud and configure the easy to instance as a web server to host our web application and access the web application from our external network from the client side perspective, right? And we have seen various uh, some of the practices that we need to configure to make our web application accessible to the end users, including the DNS mapping. It includes the the security group port number related stuff, and we have already seen the IAM role related permissions that we can configure to the EC2 instances and various other stuff, right? As a whole, as I always keep saying that our goal is to make our AWS infrastructure is fully ready to host our web application, and our goal is to make your web application is fully up and running, accessible to the end users. Are we good with this? Even when you get into the real time, right, in the working environment, always your goal is to keep your web application is up and running always without having any issues. Whatever is needed for you to do to make your web app is running, you are the responsible guy to sorry to ensure that that is being implemented and maintained properly. So I think that's good thing, right? So I hope you are able to hear me, guys. I just need to ensure that the network is properly connected. Thank you. Right, and so today I'm going to get started with some of the networking basics, guys, and at least from my sense, understanding the network concepts is little a tough concept compared to any of the concepts that we have in our curriculum, including the DevOps and any other further upcoming concepts, guys. Right, so I'll try to make it a little more easy, but yeah, definitely it will be a little complicated to understand, especially for the folks who are is completely new to this networking, right? So again, we don't need to have too much depth of understanding the networking from the networking administrative perspective. We just need some of the basics, right, which will be helping us to work as a engineer to manage our infrastructure, right, as part of our responsibility to make our web application deployed, accessible, and operational, right? So to get started with, I have few slides with me to go over with these networking basics, guys, and I'll run through those basics first now, right? Well, so as part of this networking, right, there are certain terminologies that we should be familiar with, right, when we are dealing with any of the networking stuff, right? We need to understand what is the meaning of network, IP, subnet, IP classes, port, protocol, service, daemon, like public and private IPs, right? Public and private subnets. So pretty much these are the some of the high level terms that we should be familiar with. Okay, and I'll be explaining all these different terms that we are using here and what will be the use case of that. Okay, and whatever I'm discussing now, right, this is the very general networking concept which will be applicable for any platform. This is not specific to Linux. This is not specific to AWS, guys. This is very general networking concept with respect to the systems in operational state, right? Once we know this general networking basics, then we will be transforming this knowledge into the AWS. Then we'll see how this will be configuring in the AWS cloud environment to configure our infrastructure as per our requirement, right? So far, we have deployed the EC2 instances without knowing about the networking, right? We were able to use the IP address as well to logging into the EC2 instances from your party without knowing what is IP. But yeah, the time now to understand what is this IP and how these IPs are operational and how we can configure them as well, right? So as part of that, first let me talk about the terminology called network, right? So ideally, if one computer is actually communicating with another computer, then I would say that these two computers are in the network, right? Again, rather me using the terminology called computer, I can use the terminology called server, right? Both are same, correct? The computer, the server, both terminologies are kind of synonyms, right? So based on the use case, based on the size, based on the responsibility, we may use the terms there and there, but right, from the technical perspective, both are same, right? Being said that, let's say I have a server A and I have a server B, right? If these two servers are connecting each other, these two are communicating each other, then I would say that the both servers are in the network. So if you ask me what is the meaning of a network, network is the communication that is established between more than or at least more than one computer. Could be two, it could be more than two, but at least there will be two servers in a communication. Then I would say that these are in the network. Correct. Even when it comes to our general life, right? If there is a single person where this person does not have any communication, any contact with any other, should I say that this guy has a network? Usually we say that no, hey, this guy does not have any network. That means he does not have any contact or any communication with any other, right? So whenever you have contact of 10 people, let me put it that way, then you will say that, hey, I have a good network. What does it mean by a good network? I have a network of 10 people where I can be communicated with, I can exchange the data, I can, exchange some information. That's what it is, right? So the same thing will be applicable here as well, right? If you have a server which is not communicating with any other servers, then I would say that the server is not in the network. If your server is communicating with at least any one other server, right, then I would say that these two servers are in the network. Good with this statement? So in this scenario, the A and B are the two different servers, right? These two servers are in the communication. As you see that these two are actually connected through a physical cable. Maybe I can take one uh, the network cable, right? And I can put the network cable between these two servers. If these two servers are maybe nearby, let me put it that way, then I would say that these two are able to communicate, right, over this through network cable, right? Whenever the servers are in a communication, right, in order to understand or in order to identify the destination server, the server must be assigned with a unique number called IP address. This IP address is used as an identification number to identify that particular machine in the network. In this case, let's say if the A server wanted to send some information to the B server, in order to identify the B server, right, the B server must be configured or binded with one number. That number is now called as a IP address. So I would say that the IP address is the numerical identification number that is configured for each server. That IP address is used by the other server in order to identify and contact that particular guy. It's like, you take a mobile, right, and you are trying to dial to a one another mobile, right? How are you going to identify and reach the other mobile? This is all through a number, right? So in our case, we call that as a phone number, right? The number that is binded to that particular mobile, that number is used as an identification number to reach that particular device, correct? How that is identifying, how that is working behind the screen, which we are not worrying at this time, right? So the way how your mobiles are identified using the mobile number in the network, same way the servers are identified using the number which is now called as a IP address, right? Without a IP address configured for a server, your server cannot be participated in the network. Your server cannot be reached by any other servers. So configuring the IP address is mandatory for your servers if this has to be connected properly within the network with any other servers. So the today's session is a bunch of theoretical because this is the get to start guide on the networking, and we'll definitely making all whatever I'm talking here will be taken to the implementation as well. But we need to be familiar with these networking terminologies before we get into that. So here I'm saying that the server A is now configured with a IP address. Server B is also configured with a IP address. Now the both servers can be connected each other. And can I use this statement at this time? The server A and server B both are now in the network, right? As both are able to communicate each other using the IP addresses, right? So these two servers are in the network. The name of the network is network 1. So can I put a name for this network, guys? Just try to understand from our real life perspective, right? When you have a network of 10 people, usually you can put a or you can give a name for your network, right? Hey, this is the name of my network, and my network has 10 people where we usually communicate each other, correct? Something like this. So so in this case, network 1 is the name that I am giving, right? And the network 1 has two servers which are actually communicating each other. So far so good, right? So let's say I have one more server with me called C and D, right? If the C and D servers are communicating each other, because these two are connected in that way, and definitely each server would need its own IP address. Let's say the C is identified using the IP called 192.168.1.10. Let's say that D is identified with one other IP address. Okay. Now, can I say that the C and D servers are in the network communicating each other? This particular name is network 2. Can I do like this, guys? I can put a name called network 2 for the servers C and D in this case, right? So overall, can I say that in this presentation, as of now, I would say that how I have total 4 servers with me and I have 2 networks. Is this the right statement? Right? I have total 4 servers with me and there are 2 networks. The network 1 is containing 2 servers. Network 2 is containing another 2 servers. So there are 2 networks and each network has 2 servers. So the current presentation is showing. Well, so as and when I'm using some statements, right, maybe you need to support or you do not support. That way we'll know how the things are progressing, right? Maybe I'll be keep asking you some questions, guys, throughout the today lecture, right? And try to give the answers to me over the chat window, right? So in this scenario, right, the server A can communicate with the server B. Yes, obviously, right? Because from the diagram perspective, we understood that there is a cable is also connected. A and B communicated each other, right? In the same way, C and D, both servers can be communicated each other because these two are connected with a proper cable. So far, so good. So now the question for you is, do you think the server A can communicate with the server C? No, right? So from this example diagram perspective, no. Why it is no? Because I did not put any cable as such. right? So from the concept wise, can I use this statement? As of today, right, the servers which are belonging into a single network or same network, I would say, right? The servers which are belonging into the same network can be communicated each other, but the servers which are belonging into the different networks cannot be communicated each other by default. That is my statement now. Do you support? Right? So just to repeat here again, the servers which are belonging into the same network can be communicated each other, but the servers which are belonging into a different network cannot be communicated each other by default. So the by default, that terminology is underlined here because by default, A cannot be communicated with C, B cannot be communicated with C because those are belonging into two different networks. If you want to make a communication, it is possible, right? But by default, it will not work. Take example like I have a network of 10 people. Maybe you have a network of 10 people. Maybe by default, I can be communicated with my people which are in my same network, right? Not with your network people. Until unless there is a communication is established between the two persons of two different networks, right? So that is not by default. Someone like we need to go and do some extra configuration, do some settings changes and make a communication. Then it is possible, correct? But for now, the statement is the servers which are belonging into the same network can be communicated each other, but the servers which are belonging into different network cannot be connected each other by default. Good. So this statement is really important, guys, when it comes to the AWS. Okay. Now, why the IP addresses is in this format? Usually, if you take your mobile, right, the one which is identified in the network, the mobile has one number, the number has a specific format, right? Usually the network provider will know what will be the format of your mobile number. Usually it will be like a 10-digit number, right? Having some like the country code, something like that, right? That's the standard format that they have made. Maybe that is the format that it works to generate a unique number to identify a particular device, right? Same way, when it comes to the computer communication, right? So the IP address should be followed certain standards. I can't go and give the number the way how I like it, right? So there are certain standards that are designed or defined by the organizations. We need to follow the same standards when I'm configuring a IP address to my server that can be identified in the network. The IP address that you see in this example, right, like 192.168.1.10, this is the standard IP address format, which is also called as a decimal IP address format, right? So this decimal IP address format says that your IP address should be having total 4 fields. If you see here, 192 is one field, 168 is one field, 1 is one field, 10 is another field. So it has total 4 fields which are separated by a dot. That's a standard pattern, guys. Okay. So from the technical perspective, right, each field, whatever the number that you see is called as a octet, right? So now the decimal IP that I have taken here as an example, this is the IP. It has a 4 octets. Like each field is called as an octet. There are 4 octets and separated by a dot, right? The rule says that your IP address should have total 4 fields separated by a dot. Each field should not have a number more than 255. That's the rule. Let's say here I'm using 192. In that 192 place, it can be any number from 0 to 255. You can choose any number that you like it, but the number should be 0 to 255 range. You cannot have a number 256 over there. That's the only rule that you need to follow, right? So it could be a 192, it could be 191, it could be 254, doesn't matter. You decide what is the number that you wanted to assign, but make sure that your number is 0 to 255. You can't use the number beyond 255. That's the rule, right? By following that rule, I just come up with one IP address 192.168.1.10. It could be that just a example number that I have taken, but it could be any number that you like it by following the two rules that I have said, right? So by following these rules, I constructed one IP, right? 192.168.1.10, right? So which is called as a decimal IP, right? So which is also called as a IP version 4, IPv4. So the IP that I've used here as an example, right? This IP is also called as a IP version 4. What is IP version 4? IPv4 is the format of the IP that I have used here. The organizations who decided that this is how the number should be, right? Those made some rules, and that rule is named as IPv4 IP address. So here I am using IPv4 IP address. IPv4 IP address has the standard rules. The rule number 1, it should have total 4 fields separated by a dot. The rule number 2, each field the number should not go beyond 255. Okay, I'll follow the IPv4 rules, and I taken one sample IP address here. The IP that you constructed by following this IPv4 rules, right? This IP is in the decimal format. That means this IP is a human readable or human understandable format. Once you define or decide your IP and give this IP to the server, right? When it comes to the server communication, let's say when server A is trying to connect to the server B, of course, the IP address is 192.168.1.20 in this case here. But when it comes to the communication, right, your decimal formatted IP address will now be converted it into a binary formatted IP address behind the screen automatically. I think most of you folks already know, right? The systems, the machines will be understanding anything in the numbering format, correct? Like alphabets, the numbers start from 1 to 9. All these are for our understanding purpose, because we can easily understand or remember, right, in terms of the alphabets or in terms of the numericals start from 1 to 9, right? But when it comes to the machinery, the machines can understand anything in the 0 and 1s format only, right? Which we call it as a binary format. So in the backend, automatically your IP address will be converted into a corresponding equivalent binary number for you. So in this case, you see, right, the 192 is actually converted into a binary number, which is in zeros and ones. 168 is converted into binary. 1 is converted into binary. 10 is also converted into binary. We really need not to understand how and what is the process, what is the logic behind that it is converting into into binary. We don't need to worry about that, right? Just understand that in general, in the backend, right, your IP address will be converted into the binary format, because that is the actual format that the machines can understand the destination. The decimal formatted IP is for our understanding purpose. The converted binary is for the server's understanding purpose when it comes to the actual communication, right? So when it is dividing this decimal IP into a binary format, each octet, right, each field is converted into a total 8 bits. If you see, right, 192 is now is converted into 8 bits, 168 is 8 bits, 1 is 8 bits, 10 is 8 bits. Total, your IP is now converted into 32 bits. So now my statement is any given IPv4 IP address length is 32 bits. Are we good with this? Right? Any IPv4 IP address length is 32 bits. So because your IP address is converted into the binary format, in the binary format, total number of bits will be 32. That's the reason IPv4 IP address length is 32 bits. Now a question for you at this time, right? Maybe uh, the best way to understand the networking is by taking more examples and more scenarios, guys. Okay. Now the question for you, do you think, right, the the server A and server C, do you think can I give the same IP address for these two servers, A and C? In this presentation, as of now, I given 192.168.1.10 for server A, 192.168.1.10 for server C also. Of course, the IP address is following the rules, correct? I have two rules. The rule number one, the IP address should have total 4 fields. Yes, it has. Rule number two, the number should not go beyond 255. Yes, it is following. The rules are following. IP address is valid, but can I use the same IP address for both servers? Right? So to answer to that, it is possible to give the same IP address for multiple servers as long as those servers are not into the same network. Let's say I have a network of 10 people with me, and I do ensure that there will be no duplicate names within my network to avoid the confusion, correct? I don't mind if anyone else is having the same name in the different network of people, correct? Maybe you have your own network of 10 people. Do I worry about the, the if you are using the same name in your network people? I don't. Why? Usually my network people are not communicating with your network, right? As long as there is no communication is established between the two networks, why should I be worry about whether you are using the same IP or same number? You got me what I'm trying to, right? So that means the answer for this is it is a valid to give the same IP address for multiple servers as long as the servers are not falling into the same network. So here the A and B are belonging into one network, C and D are belonging into another network. A, B are not having any communication to C and D, right? So why should I be worry about if C is having the same IP number? I don't care. Hope you are trying to understand me, right? So in the network one, I should not have any duplicate IP. Within the network two, no, I should not have a duplicate IP. But the IP that is being used in the network one, yes, that IP can be used in the network two. I don't care because there is no confusion or there is no duplication over there, correct? Being said that, now let me give you one more example here, right? So here I have a few more servers with me, right, to give you few more examples, right? Now my statement is like this. E and F are the servers which are belonging into a network called 192.168.1.0. Only the difference here now is rather me calling the network with the network name, even the network is identified using the IP address format. Like previously I was saying that A and B servers are in the network 1. Now my statement is E and F are the servers which are in the network. The network is 192.168.1.0. Are we good with this? The only change is rather me specifying the network with the name, I'm using the network name replaced with a IP format. That's it. Why? You know, right? The systems will never worry or never work using the naming convention. The names are for our understanding purpose only. When it comes to the computer communication, the computers will always happy to work in terms of the numbering system only, right? That's the reason slowly I'm changing my network names into a IP format, right? So the IPv4 rule says that not only the IP address that is assigned for a server, even the network name also should be identified using the IP address format only. That's the standard rules. Hence the reason the network one I just replaced with a IP formatted number. In this case, 192.168.1.0 is my network ID. If you slowly look at this, guys, 192.168.1.10 and 192.168.1.0, these two look like IP addresses, right? Both are IPs only, correct? Both are IPv4 addresses only because both are following the same rules. It has 4 fields. Each field is not exceeding more than 255, right? If these two rules are followed, yes, that is IPv4 address. But from the understanding perspective, right, the 192.168.1.10 is the IP address because that is actually assigned for a server for identifying the server. But do you think 192.168.1.0 is the number that I have considered here as an example? Do you think this 1.0 IP is used here to identify a specific server? No, right? The 192.168.1.0 IP is being used to identify the network, correct? 1.0 is not for a specific server. No, this is for identifying the network itself. So from the terminology wise, 192.168.1.0, sorry, 192.168.1.10, I am calling it as a IP address. 192.168.1.0, I am calling it as a network ID. Are we good with this? Right? So if you ask me what is network ID, network ID is the IP address which is used to identify the network itself, not a specific computer. So in this case, the network ID is 192.168.1.0. The other scenario you see here, the G and H, these two systems, right, are in the network ID called 192.168.2.0. Just to repeat my statement one more time, right? The E and F are the two servers which are belonging into 192.168.1.0 network. G and H are belonging into 192.168.2.0 network. Are we good with this statement? Now my another statement is all the servers which are belonging into 192.168.1.0 can be communicated each other. All the servers which are belonging into 192.168.2.0 network can be communicated each other. But the servers from 1.0 network to 1.2.0 network cannot be communicated as they are belonging into two different networks. So the communication between the two networks will not be happen by default. Whatever I did discuss some time back, I'm repeating the same step. This time I just replaced my name of the network to the network ID concept. Right. So being said that, maybe now whenever you have multiple servers with you, let's say in this case I have total 4 servers, right? Let's say I have multiple servers with me. What is very important in this scenario? The important here is how do I understand the given two servers are belonging into the same network or not, correct? That is most important part, right? When I give you two servers, how do you know these two servers are belonging into same network or belonging into a different network? That is most important. Why? If they are belonging into same network, they can be communicated. If they are belonging into two different network, they cannot be communicated, right? Hence the reason it's very important for us to know the given two servers, that means the given two IP addresses are belonging into a same network or a different network. Here in the presentation, you can easily tell that E and F are into one network, G and H are into another network, because I made a diagram in that way, right? But let's say you don't have a diagram like this, and if I give you the two IP addresses, right? So let's say I will give you the IP is called 192.168. Maybe I feel better here, right? I will give you 192.168.1.10. I will give you 192.168. Let's say 1.30 as an example, guys. So these are the two IPs that are actually configured for two different servers. Now, if I give you these two IPs, if I ask you, hey, can you tell me these two IPs are belonging into a same network or not? Can you? Right? So that's what is needed here. So whenever you have two IP addresses, you should be able to determine these two are belonging into same network or not. Why? That is actually important to know whether these two IPs can be communicated each other or not. If they are into a same network, yes. If they are into different network, they cannot be. Right? You will not be having this diagram every time, right? That's how it is. Good. If that is the case, right? Yeah. If that is the case, let me ask you something like this. Right? Let's say I'm trying to build my own data center. In my data center, I purchased almost 300 servers. Now I will ask you, hey, I brought a brand new 300 servers. Now I want to configure the 300 servers with the IP addresses, right? And my requirement is all these 300 servers should be communicated each other. I'm using these 300 servers for my business, same business, right? All these 300 servers should be communicated each other. Then what is your plan from now onwards? So when it comes to the requirement, right? The requirement says that, right, all these 300 servers should be communicated each other. So what is your plan now? You want me, you would like to keep all these 300 servers into a same network? Is that the plan? Right? The business says that, hey, keep these 300 servers into a single, sorry, keep these 300 servers into communicative each other. That's the requirement. So far what we know, if the servers are into a same network, they can be communicated each other, or else no, correct? So then to achieve the communication between these 300 servers, we need to put them into same network, correct? Then we need to decide the 300 IPs, correct? We need to decide the 300 IPs now. Maybe this is a better font, right? So how do you decide the IP addresses, guys? Right? I'll go randomly for now. Let's say I'll go with 192.168.1.1. This is the IP address for my first server randomly. Okay. Let's say 192.168.1.2, right? Let's say 192.168.1.3 and so on, correct? Let's say 192.168.1.255. So sorry, 192.168.1.256. So if you look into this, right, maybe till 255 it is okay. It is following the IPv4 rules. So do you think I can go and take the IP address called 192.168.1.256? No, because that is violating the rule. The number cannot go beyond the 255. So maybe uh, from first server to 255 servers, I just took some random number and I configured. Now I can't go with the 256. Then what is your plan now? What is the IP that you wanted to give to the 256 server that I wanted to communicate with the rest of the servers? Got me? Maybe I'll just go with 192.168.2.1. But whenever you go and take a random IP just like this, how do you ensure that these IPs are belonging into the same network? You got me? What is the point, or who is telling that these IPs are belonging into the same network? Correct? Hence the reason you cannot take a IP address just randomly and configure. No. So before you decide what will be the IP address that you wanted to use for your server, right? You need to decide your network ID. If you go back to this screen one more time, guys, if I go back to my presentation here, right? You see the network ID 192.168.1.0 is the network ID that I have considered, right? This network ID is now a trigger point, right? So if all my systems are belonging into this network ID, they can be communicated each other. That's how my statement was. That means before you go ahead and decide your IP address, first you need to decide your network ID. First, let me decide a network ID. Then we'll figure it out what and all IPs may fall into that particular network. Isn't it sound good? Correct. So how do you decide a network ID first? Any network ID that you are trying to decide, right? Any network ID that you are trying to plan, the network ID should have same rules. It should have 4 fields separated with a dot. Each field should not go beyond 255. Same rules, because the network ID also in the form of a IP address format only. The format is same, right? So I'll go with this network ID 192.168.1.0. Usually, any network ID that you choose will be ending with 0. Usually, any network ID ending with 0. That's not a true all the case, but initially to avoid the confusions, let me put it as, right, network ID ending with 0, guys, right? So now I'm taking that, hey, this could be a network ID that I wanted to use to configure the IP addresses for my 300 servers. I'll plan like, okay, I just took some random network ID. Now I'll keep all my 300 IP addresses into this particular network ID. Then my problem is solved, right? Got me? Right? So it need not to be 192.168.1.0, guys. It's up to you. What is that you wanted to take on? It can be 192.168.1.0. It can be 178.13.4.0. It's up to you. It should have just total 4 fields. Each field should not go 255, beyond 255. Those are the only 2 rules that you need to follow. Maybe the third rule is ensure that that is actually ending with zeros. Then you are good. Maybe you can help me with some of the network IDs that you think of in the chart window as well. But for now, to make it more easier, maybe I'll go with the 192.168.1.0 is my network ID, which is actually ending with 0. Whenever you decide one network ID based on your preference, right? Is my font is still visible, guys, properly? Good, right? So yeah, whenever the network ID is defined like this, it says that your network ID usually will be get divided it into 2 parts. Yeah, that is what it is. It is little shaded. That's the reason. Let me go with pen. Sorry, notepad. I think this font should be little good. Yeah. So this is the network ID. So usually, right, the network ID is divided it into two portions, right? So your network ID is divided into network part plus the host part. As of now, blindly I am saying that in the network ID, whichever the non-zero numbers that you see, all those non-zero numbers are belonging into the network part. Wherever you see the zero, that is called as a host part. That means when you are trying to create a IP address that is belonging into this network, ensure that your IP address network portion is same. Maybe a question for you at this time, guys. What is my goal? My goal is I wanted to create 300 IP addresses that are belonging into this particular network ID, correct? Are we good with this requirement? Because I have 300 servers that needs to be communicated each other, and I'm planning to create a network ID and create 300 IPs, and I need to ensure that all the 300 IPs are into the same network. Then only those can be communicated. That is the knowledge that we have so far, right? Being said that, is it the right expectation at this time? I wanted to generate a IP addresses that must be belonging into this network ID, correct? If then, if then, how do you ensure that the IP that you are trying to generate, right? The IP that you are trying to generate that you wanted to use for your server is belonging into the same network. The rule says whatever the network ID that you defined, ensure that your network port is same. So now if I want to generate a IP address, your IP address should be like this: 192.168.1.1. Another IP address is 192.168.1.2. The another IP address is 192.168.1.3. The another IP address is and so on. Maybe like that I can have multiple IPs. Finally, 192.168.1.255. So now the question for you guys, all these 255 IPs are, can I say that all these 255 IPs are belonging into the network ID called 192.168.1.0? It can be possible. How can we say that? The way how it works, right? Whenever you have taken a IP address and the network ID, you always compare the IP with your network ID, right? If the network part is matching in your IP address, then I would say that this IP is actually belonging into this particular network ID. So whatever the host part that I used to say, right? The host part can be changing. You see here, only the host part is changing. The network part is same across all these IP addresses. Hence the reason I would say that all these 255 IPs are actually belonging into this particular network ID. So now let's say if I go with one more IP called 192.168.1.256, this is not a valid IP, right? Because I can't go with more than 255. So hence the reason the last portion cannot go more than 255. So maybe I'll try to change my, right, the third position. Maybe I'll go with the 2.1. Now tell me guys, in this scenario, do you think the 192.168.2.1 IP is belonging into this particular network? No, because the network ID that you have considered here is 192.168.1.0. In this, The network part says 192.168.1. Whichever the IP that you take on, right? The IP, the starting three positions, three fields should be matching. Here it's not matching. So the 192.168.2.1 IP is not in the same network. So then, can I keep the IPs in the same network, all the 300 IPs in this scenario? I can't. So the network ID that I have considered here, this network ID is helping me to generate only 255 IPs that I can assign. I cannot generate 300 IPs by using this network ID, correct? That means the network ID that I have considered here is maybe a wrong choice, wrong decision. If your requirement is to keep 300 IPs in the single network, maybe the network ID that I have taken here is not sufficient for me, because this is helping me to generate only 255 IPs based on the rules that I have. So if you give 2.1 IP for a different server, this server cannot communicate with these servers because it is treating that the 2.1 IP is not into the same network, because it is always comparing with the network ID. Now, a question for you guys at this time. I will give you only the IP addresses like this. Now, is it possible for you to tell the IPs are belonging into which network, or maybe are into same network or not? Now tell me, can you say 192.168.1.1, 192.168.1.2, these two IPs are belonging into same network or not? Can you say with this information? How do you say? Without a network ID, with you, I remove the network ID in this diagram, right? Without a network ID with you, you cannot determine by looking into the IP itself, guys. Correct? Because the network ID will tell you in the IP addresses how many portions that should match with the network ID to know which they are into a same network or not, right? So without knowing the network ID of a IP address, we cannot understand that IP is belonging into which network, and there is no answer for me. I would say, if you ask me now, 192.168.1.1 and 192.168.1.2, if these two IPs are belonging into same network or not, I would say I don't know at this time, because without knowing the network ID of these IP addresses, we can't tell the answer, correct? So we need a network ID for sure. That means when you are giving the IP address to your server, you cannot give only the IP, guys. You have to give the IP plus the network ID. You need to configure both to your server every time. Following me? For server A, for server 1, when you are configuring the IP, you need to tell that, hey, this is your IP, this is your network ID. Second server, hey, this is your IP, this is your network ID. So for every server, you need to tell what is the IP of the server plus what is the network ID of the server. You need to tell both parameters. Are we good with this? Then only your system know that the IP is belonging into which network. Then only it can understand that which systems are part of the same network. In real life, right? Let's say I have 10 people in my network. How do I know all these 10 people are into the same network, or into my network? First of all, maybe for everyone I'll give one network number. Hey, if you show this number, then only you will be part of my network, or else no. Let me put it that way. Correct? Right? If anyone is coming into my network without showing that number, the network ID, no, you are not my network. Where is your network ID? Show me. Something like that, right? So every system that is configured must be having a IP plus the network ID also associated to that. Are we good with this? So the statement here is, without knowing the network ID, it is not possible to tell the given IP is into which network, or not possible to tell the IPs are into same network or not. If we are good with the statement, now my next scenario is like this. If you take the network ID that I have considered here as an example, right? If you closely look at this network ID, the network ID has total 32 bits, correct? How many bits are there, guys? If you are converting this ID into binary format, usually it will be 32 bits. In this 32 bits, if you closely look at 8 plus 8 plus 8, 24 bits are using to identify the network. 8 bits are used to identify the computer or a host, correct? If then this network ID can be notated in a shortcut by using a /24 kind of. So this network ID I can say a /24 network. So this is just a shortcut representation. This /24 shortcut representation will tell that in the given network ID, 24 bits are used for network identification. The remaining bits are used for host identification. That is just a notational wise representation, guys, /24. So whatever the /24 that I'm using here as a notation, this is called as a CIDR notation from the terminology wise. I'll show you. I'll talk about what is this CIDR full form and all, but for now, this /24 is the CIDR notation. If then, now let's say I'm removing this whole network part. Again, come back to the same scenario, guys. If I ask you a question, hey, tell me 192.168.1.1, 192.168.1.2, these two IPs are belonging to same network or not? Can you give the answer at this time based on the information that you see in the screen without having a network ID? No, right? But rather me giving you the full network ID, I can go with the shortcut CIDR notation. So in each IP address, I can say a CIDR notation like this. I'll do like this. So now tell me, guys, is it possible to tell that these highlighted IP addresses are belonging into a same network or not? Now I can tell why. The CIDR notation is helping me to understand in this given IP address how many bits are using for the network identification, and all of these IPs are in /24 CIDR network. So I would say that 192.168.1 is the network part. The network part is same across all these three IPs, and definitely all these three IPs are belonging into the same network. Now, from this IP address with a /24 notation, if I ask you what will be the network ID of these IP addresses? What will be the network ID of these three IPs? The network ID will be 192.168.1.0. You just, when it says /24, just take the 24 bits from this IP and the last portion will be a 0. That's how we can, make the actual network ID from the notation as well, from the shortcut. Now, being said that, can I use this statement at this time? Whenever you use /24, sorry, whenever you use /24 as a network ID, now I'm just using the shortcut, okay? Whenever you use /24 as a network ID, I can generate maximum of 255 IPs, correct? sorry, right? So maximum I can have 255 IPs, right? Let's say if I use the network ID as, like in general, /24 means what? Like 2 power 8 equal to 256. It actually 256, not 255, because it starts from 0, right? 0 to 255, which will be like 256. Okay. Let's say if I do a /16, if I use the network ID as /16, then it will be like 2 power 16, and you do little calculation, guys. So that will be the number of IP addresses that you will be getting in, correct? So when you do a /16, that means the 2 octets will be used for the network identification. The remaining 2 will be used for the host identification. That time 8 plus 8, total 16 bits will be used for host purpose. So the probability will be increased and you will get this many number of IP addresses. If you do the calculation, it will be somewhere around 40k or somewhere around 45k something. So if you go with the /24, you will get 256 IPs. If you go with the /16, you will get 45k IPs, unique IPs. So I can keep 45,000 of IPs into a single network if I go with the /16 CIDR block. That's how it works, right? So same way, let's say if I go with the /8 CIDR block, it will be like 2 power 24, and you do little calculation. So 65 for this one, I believe. Yeah. Now you do some calculation, you will get this many number of IPs. So the network ID is actually deciding how many number of IPs can be keep in a single network. So whenever you get the total number of servers brought into your data center and you wanted to configure them, right? So based on the requirement, you need to decide which network will be more suitable for you. Maybe at this time, if I wanted to have 300 servers configured in the single network, now tell me guys, which CIDR block that I wanted to go. Do you think /24 works? No, right? Because /24 will give us only 256 IPs. To get 300 IPs in the single network, maybe I need to go a different network ID, which can give me at least more than 300 IPs, something like that. So we need to do the calculation, which network ID will give us how many IPs, then you go with the specific network ID only for your use case, right? The IP addresses or the network ID that you are following the /24, that IP addresses are called as class C IP address. The IPs that are following /16 CIDR, that is called as a class B IP address. The IP addresses that are going with the /8 is called as a class A IP addresses. The organizations are defined some standard classes for the IPs based on the network that you are choosing on. I will give you some examples now. If I go with the /24, right, the example network ID will be like this. 192.168.1.0 is the network ID. The IPs will be like this: 192.168.1.1 to 192.168.1.255. Are we good with this? It can be 192.168.1. It could be any other. Just ensure that /24 is followed. So the 3 octets are using for the network ID. This is CIDR. Okay. So let's say if I go with a /16 as the CIDR. Now give me some example, guys. What will be the network ID for this? right? Maybe I'll do like this. Okay, maybe 192.168.0.0. That's how it works. You see, right? Now, if you ask me the IP addresses for this 192.168.1.1, maybe 192.168.1.255, then 192.168.2.1, and so on 192.168.255.255. It will be going on for 65,000 total. So at this time, all these IPs are belonging into same network. Why? You see in this scenario, 1.1, 2.1, both are into the same network as per my scenario. Why? Right? When it is slash 16 CIDR, I need to worry about only the 2 octets. If the 2 octets are matching, yes, these are into the same network. So the 1.1 IP is slash 16. The 2.1 is also slash 16. So this CIDR will tell us exactly the given IP is into which network, and that's how we need to do the comparison. Right? You can take any IP that you like it, right? It can be like, for example, 192.168, sorry, 0.1. Why not? I can take this IP also. So I just need to worry about the 2 octets or network identification. Remaining whatever you use, that is just a host part. It can be, not a worry. So this IP also, I can go with slash 16 CIDR block. So that's how it works, right? If you go with the slash 8, you just need to worry about only the starting portion. The remaining all three can be any number. That's how we need to understand the given IPs are into same network or not. So at end of the day, this is confusing, right? Because I have to always depend on the CIDR block to know whether the IPs are into same network or not, correct? Because if I take this example, 192.168.1.0/24 and 192.168.1.2.16. Now tell me guys, these two IPs belonging into same network or different network, right? So these two belonging into different network, not same. That's where the confusion now. Look like the IPs are same. 1.0, sorry, I'll take IP address here, maybe 1.1, right? So you see here it is like 1.1, this is like 1.2. Look like both are same, but when you look into the CIDR, the CIDR tells that the first IP is into 192.168.1. Series. The second IP is into 192.168 series. I just need to consider only 16 bits from there. So each time depending on the CIDR is really uh, makes us confusing or dependent on this number, right? To avoid this, the organizations are set some uh, standard numerical assignments for each class that you are trying to, just for avoiding these confusions, right? So let me go with that. You see here the private IP address forget about private IP, just look into the IPs guys. If you are planning to take /24 CIDR block IP address, you always take the IP in between the range of 192.168 to 192.168 to 55 to 55. So if you take any IP between this range, you ensure that that is actually in /24 CIDR range. If you are taking any IP between 170 to 16 to 170 to 31, in between, you make sure that your IP is actually following /16 range. If you are taking the IP from 10 number onwards, then that is /18. These are the standard IP classes that everyone will be following in the industry. There is no rule that we how to follow this, but if you follow, this is a best practice. So if you are following this pattern, right, then you don't need to worry about the network CIDR number. Without looking at the CIDR, it is even possible to tell the given IPs are belonging into same network or not. For example, now let's say I am following the IP classes. Now I'll give you only the IP addresses. You take this example, guys. I'll give you two IPs for you. 192.168.1.10 is the another one IP. 172.31.4.5. This is the another IP. Now tell me, these two belonging into same network or not? In this example, I have not given you the CIDR block. I have not given you the network ID, but still it is possible to tell these two belonging into same network or not just by looking into this number. Any IP that is starting with 192, right? That IP must be in the /24 as per the standards. Any IP that is starting with 172.31, yes, that should be in the /16. That is how we need to understand, guys. So the IP that is starting with 192 is the class C IP address. The IP that is starting with 172 is the class B IP address as per the guidelines that we have here. But again, whether you follow these guidelines, you don't follow the guidelines is up to you, but following these guidelines is really best practice. In the sense, can I configure the IP like this? 172.31.4.5, I wanted to configure this IP in the /24 CIDR blank. Will it work? If I give the IP to my server with the /24, will it work? It will work. Your computer will not complain on this. That's what I'm trying to say. Right? Your computer will not complain. It will take on. It will take on. It will tell that okay, this IP is in 172.31.4.0 network. That's how it will understand and it will start working. Right? Your computer will not complain on this. It will take in. Whatever the CIDR that you give, it will take on. There is no complaint. But this is not a best practice that you have to follow. The people will confuse. Whoever is looking into the IP, they will think that this IP is in the /16, but you made it into /24. So this is not the right way to configure, but if you do so, your systems will not complain. That means my statement is like this. The IP address rules that I have defined here, these are just a best practices. If you are not following this, your systems will not complain. Are we good with this? Right? The rules are defined just to make your life easier, but there are cases where the people will not follow as well. If you follow, this is well and good. Being said that, now my statement is like this. Assume we will be following these IP class rules, right? We'll be following these IP class rules, right? Uh, then whenever, whenever, yeah, whenever you have some number of servers that you wanted to configure in your data center in your same network, right? The very first thing that you need to do is think about which IP class that you wanted to use for this use case, correct? I'm just changing my terminology, that's it. Rather using the term called CIDR, network ID, all these, I'm just using the higher level term, right? Should I go with the class A, class B, class C? That is what is the decision that you need to make out first, right? Because the class C will give you 256 IPs, class B will give you 65K IPs, class A will give you some more extra IPs, right? So first you need to decide which class that you wanted to consider here to configure the IPs for your server in your data center. Are we good with this statement? If then, right, The class is the one which is deciding how many IPs that you wanted to. Good. Right? Of course, indirectly the CIDR is the one which is deciding. So now my question is, can I go with the CIDR called slash, I would say slash 22? Can I go with slash 22, guys? What is slash 22? That means in the total 32 bits, right? I would say 22 bits for network identification purpose, right? And remaining maybe 10 bits are using for the host identification purpose, correct? As per the concept, the total 32 bits, right? Whichever the IP that you use, the IP is converted into 32 bits, right? In that 22 bits for network purpose, 10 bits for host purpose possible. So in this case, if you use slash 22, you will get 2 power 10, this many number of IPs that you can generate. So slash 24 is not a class, guys. Only slash 8, slash 16, slash 24 are the standard IP addresses or IP classes that the organization has announced. Anything that you take on any other CIDR block, that is the classless. There is no class for this, but still it is possible that you can configure slash 22 also to your systems. That's where this notation is called as a CIDR notation. Why I call it as a CIDR? The CIDR notation is classless interdomain routing system. That means this is the notation that is representing how your IP address is divided it into network and the host part. So based on the requirement, like how many servers that we have, how many servers that we wanted to keep in one single network, based on the requirement, we usually take a decision. Do we go with the class A, class B, class C, or classless, maybe like slash 22? We take a decision based on that. In general, what do you think in real time, which CIDR network or which class is that mostly we will be using in, right? So mostly we go with the class C, which is giving 256 IPs, right? That's more than enough. You will not be keeping more than this many in one single network. So this is good enough. At worst scenario, you go with the class B, that is good enough to give you 65K IPs. That's even more good. Now, to conclude this whole statement, if I ask you, hey, I have 300 servers that I wanted to configure to be in a single network in my data center, what is your plan, guys? Which class that you wanted to prefer now? Maybe I'll go with class B for now. I'll just go with class B. I'll go with slash 16 CIDR block, and I'll go and take the IP that start with 170-31 series, which is as per the best practice that the organizations has decided. Good. So out of this whole story, I spent a lot of time, but out of this whole story, what is that we need to make a note? Whenever there are two given IP addresses for you, you should be able to understand the given IPs are belonging into same network or not. If they are into same network, they can be communicated each other. If they are into different network, they cannot be communicated each other. If they are into same network or not is something is decided by the CIDR notation or network ID in a way. Are we good with this? Now, I'll give you a little more information here. You see this diagram, guys. I have a server A having some IP address, and now you see along with the IP, I'm also giving you the CIDR notation here, because that CIDR will tell you now, right? The IP is into which network, correct? Or else we don't know. So I have a server A, server B, server C, and the server D. Since I have more number of servers, right? In order to make them communicated, I bought a switch. Whatever you see in middle, right? That is a switch. Like if multiple servers has to be connected each other, usually you can take the switch and you connect the cable to that switch, and the switch will take care of putting the connectivity for all these machines, right? Now a question for you. Do you think the server A, right? The server A can connect with server C? You have all the information handy, right? So the server A can communicate with server C in this example, right? The answer is no. The reason is the server A is into 192.168.1.0 network. Server C is into 192.168.3.0 network. Both are two different networks, right? As we know, the servers which are belonging into two different networks cannot be communicated each other. As it is /24 CIDR block, I'm just starting 3 octets into my consideration. But still, if I want to make a communication possible between these two networks, then rather using the switch, because the switch usually provide a connectivity between the networks, within the network. Still, if my server A want to connect with server B, which is not possible by default, then we need to keep a router in between. What is router? Router is also called as a gateway from the terminology wise. Okay. Gateway is the kind of a device which can be used to connect the systems which are belonging into different networks as well. In this scenario, if I keep the gateway between a server A and server C, it is possible that the server A can also be connected with the server B, though these two are into two different networks. So can I use the statement now after having this? If we have the systems belonging into two different networks, and if you wanted to make a communication possible between these two different networks, we need to keep a gateway in between. Are we good with this statement? Right? The gateway has to be established between the two different networks if you are still looking for a communication between those two. Then it's possible. So now the statement is, right, the gateway is used to route the traffic from one network to another network. Good. Now this is the final slide to conclude our networking basics that we need. Let me run through this. What is our goal? My goal is I wanted to keep my servers in my data center configurable. That servers I will be using to my business. Let's say I have a data center with me. Correct, no? All the servers will be putting into a data center, right? We know already what is it mean by the data center, right? The data center is the building space where you will be keeping all of your servers it into your racks and do a communication there, right? That's the data center. So I have a data center here. In my data center, I wanted to keep my servers. The very first thing that I will be making a plan, correct? When I'm keeping my servers in the data center, first I should make a plan, right? What should be the network ID that I wanted to use in my data center? What should be the IP addresses that I wanted to use in my data center? Correct. We should have all the plan ready. Then you go and start configuring them, right? So here for my data center, I wanted to use the CIDR block as 192.168.0.0/16. What does it mean, guys? All the servers that I wanted to keep in my data center should be following my /16 CIDR block notation. Are we good with this? And can I go with 192.168.0.0/16? Is it legal or illegal? It is still acceptable, right? It is still acceptable. Whatever the best practices that I talked about some time back, right? Those are best practices. Whether you follow, whether you don't follow, that doesn't matter, right? So I'm going with this plan for now. Now I'll go and start putting my servers into my data center, and you see that I put some two servers here, the server E and server H. For server E, I put the IP called 192.168.1.10. For server H, I am putting one other IP address, something like this. Now E and H are in same network or different network, guys? Based on the data that you see in my screen. As of now, based on the data that I see, yes, E and H are into the same network, right? Now, it is possible to divide your network into subnetworks as well. You see now, when I'm configuring my IP address to my server, I'm not configuring the IP in the /16 CIDR, rather I'm configuring the IP in the /24 CIDR. So now I would say my statement is like this. E machine is in the 192.168.1.0 network. H machine is in the 192.168.2.0 network. Following me? Yes, it is possible. So the E is in one network, H is in another network. But yes, E and H both are into the same network, which is /16. I'm not denying that. That means the /16 network, again, I'm dividing it into multiple networks here to satisfy my requirements possible. Like one big network can have multiple smaller networks, correct? Just in your real life, right? You have a group of, you have a network of 100 people, right? Sometimes, within your 100 people's network, some 10 people will have their own private network again. They communicate each other. They'll not tell what they are discussing, right? To the entire group of people. And just trying to correlate it. Same thing like this. So the /16 is the broader network, which I can break it into a multiple networks as well possible. But we need to follow the same rule. The smaller networks that you are making, right? The smaller network should be within the range of the broader network. In this case, you see the /24, 192.168.1.0 is still in the range of 192.168.0.0/16 only. Like in my data center, I can't use the network which is like 172.31. You got me what I'm trying to? As long as it is following 192.168.0.0 range, we can go with any network ID, which is a subnetwork now. So if you in this context, right, 192.168.0.0 is called as a network ID, and 192.168.1.0 is called as a subnetwork ID. Are we good with the statement? Network ID and subnetwork ID. Sometimes the people also call as a net mask as well. Sub network ID, net mask ID, both are same, guys. Subnetwork ID or subnet mask ID, both are same. Just a representation differences. Even the net mask, network ID, both are same. Now my question for you guys: do you think the E machine and H machine are in the same network after some changes into this? E machine, H machine are in the same network or in the different network. This is really important to know at this time. E and H are not in the same network. Why? It is divided into the subnetworks. As long as it is divided it into a subnetwork, I need to worry about the subnetwork only. Now I'm not worrying about the /16 there. Of course, it is part of /16, that I agree, right? E and H both are part of /16, that is true. But since it has a subnet, we need to consider the subnet as well when it comes to the communication. So I would say E and H are not in the same network in this context. So if then the question for you, do you think the E machine and H machine can be communicated each other by default in this case? No. Why? These two are into two different networks at this time. As I said, if the machines are in the two different network, we need to keep a gateway in between, right? So now we need to take a gateway device. Even the gateway also will have a IP address, guys. Even the gateway is also kind of a server, right? So your gateway is also a kind of a server, which is also having a IP address for identification, right? So you need to keep a gateway and connect the gateway to your servers like this. When you are trying to make a communication possible between E and H machines, in between, yes, you need to keep the gateway. It can be one gateway, two gateway, 10 gateways. It's up to you. Here in the presentation, I am keeping two gateways, but it can be 2 or it can be 10 or it can be 20. Based on the requirement, we can keep any number of gateways in between the source and destination. Good. If you look at this right slowly, the one gateway has a IP address called 192.168.2.1, which is in the range of H machine network. Another gateway is 192.168.1.1, which is in the range of the E machine network, correct? Yes. When I'm planning my data center, IP addresses are /16, right? That /16 is anything in my data center. It could be a subnet, it could be a IP, it could be a gateway, it could be any other. Anything in my data center should follow the /16 CIDR. In that /16, yes, we can make multiple subnets as well based on the requirements. Now in this scenario, if the H machine want to connect with the E machine, the H machine is sending the data to the gateway called 2.1. The 2.1 gateway will be sending the data to gateway called 1.1. This gateway is sending the data to E machine. That's the overall network path. As I said, it can be 2 gateway, it can be 100 gateways in between based on the requirement, however you feel comfortable to configure. Here I'm making 2 just to make the things simple. Now, we need to spend another probably another 15 minutes to understand this, right? So let's say my H machine is in the location called USA. Let's say my data center is in somewhere in the USA, right? And my H machine is in the USA location. Let's say I have a client who is trying to connect to this H machine. The client is in India somewhere, example, right? If this client want to connect with this H machine, right? So the client communication will always go via the internet, right? The client has to send a request by specifying what is the purpose that the client want to connect, plus the destination IP to which server that he wanted to connect, plus the protocol, plus the port number. This is the standard pattern, right? Even when I was trying to connect to the server using my PuTTY, I used to mention all this information: IP, protocol, port number 22, all these things, right? So the client is making a request to connect to the server which is in the USA. The request is going via the internet. Then the client, right, cannot connect to the H machine using the IP called 192.168.2.20, whatever you see as of today, because the 192.168.2.20 IP what you see currently for your H server, that is called as a private IP address. The private IPs are the IPs which are accessible within the data center only. Those private IPs are not accessible from outside of the data center. In my case, my client is not sitting inside the data center. The client is sitting somewhere outside of the data center and the request is coming via the internet. So your H machine must be having a public IP, whereas that public IP is available, reachable over the public internet. So in this case, your H machine should have a public IP and your client also should have a public IP. Here, the client laptop also should have a public IP. Then only the client request can be initiated. The request go via the internet using multiple gateways. Somehow the request will reach to the gateway inside the data center. That gateway will be sending the traffic to that H machine by identifying this public IP. That's how the request will be landed here. Now what I'm trying to say here is the private IP is the IP which is accessible within the data center network. The public IP is accessible over the public internet as well. Being said, the question for you at this time, if of course the H machine is now having two IP addresses, right? One is public and one is private IP. Now tell me, if the E machine want to connect with the H machine, the E machine would need to use public or private IP? Which IP can be used by the E machine to connect to H? The E machine can use the private IP because the E machine is sitting inside the same data center. The request can go via the private IP. The request may go to 1.1 gateway, a 2.1 gateway, then reach to the server. That's it. So simple. But when it comes to the public internet, the communication comes via internet from outside of the data center to inside the data center using some gateways here. And even this gateway also has a IP address. In this case, I am keeping this gateway as 2.2 gateway. Relax time. Now the question for you guys, okay? Let's say I have the H machine. The H machine want to connect with the E machine, okay? The H machine is actually connected with two gateways in this presentation, right? One is the 2.1 gateway device, one is the 2.2 gateway device. There are two gateway devices are connected to the single server. So from the diagram, we can easily understand that if the H machine want to connect with the E machine, the request will go via the 2.1 gateway. If the H machine want to connect with the client who is outside of the data center, the request should go via the 2.2 gateway. That's easily to understand, right, from this diagram. But when it comes to the reality, how would your H machine know that when it has to connect it to E, it has to go via the 2.1? When it has to connect it to a client from outside of the data center, it has to go via the 2.2 gateway. How it know this? On what basis it can choose the two different network paths that it has? Hope you got me my question, right? When you have two different ways to choose, on what basis it is choosing the one out of these two? Because we made a connection, we made a cable, we know how it works, but system doesn't know this, right? That is the reason it is important to keep your network routing configuration in a table, and that table is called as a routing table. That table has the details that for which destination, what is the target routing or the target gateway that it has to use. Mention that information and attach this route table to your servers. Now you see, when you maintain the routing table like this and give this table to your H machine, now whenever the H machine is trying to connect to the destination, then it will look into the table, then it will understand which gateway that it has to use. Let's say here I maintained a routing table saying that if the destination is in the 192.168.0.0/16 range, then you please use a 2.1 gateway. That is what I have mentioned there. Now tell me guys, if the H machine want to connect with E machine IP is 192.168.1.0, right? Sorry, 1.10, right? So when the H is trying to connect it to the E machine IP address, first it will check into the table. Is this IP falling into any network? If yes, I'll use this. Tell me guys, do you think 192.168.1.10 IP is falling into 192.168.0.0/16 range? If your E machine is into 1.0/24 network, is not mean that it is not in the /16 network, correct? When you are part of the 100 people's network, you may be maintaining your own small network with 10 people internally, but is not mean that you are outside of the 100 people network, right? You are still part of the broader network, correct? Correct. When you are part of the 100 people's network, sometimes you may be having some 10 people network within yourself to manage some stuff, but is not mean that you are out of, right? Same logic will apply here as well. So yes, the 1.10 IP is still be part of 192.168.0.0/16 range only, because we need to look at this starting 2 octets. It is comparing there. So here the destination I mentioned as 192.168.0.0/16. Yes, the 192.168.1.10, which is the E machine IP address, is still falling into this 16 range only. Yes, then it will understand that okay, the request should go to 2.1 gateway, then the packet will be delivering to 2.1. That's how it will go. The way how I'm maintaining the table should be there for your gateway as well, because how your 2.1 gateway will know that the packet has to go where, correct? Even it has a table, it will follow the table, then it understands that the request has to go to 1.1 gateway. The 1.1 gateway will have a table, then it will understand that it has to go to the next level. Like that, from source to destination, in each gateway level there will be a route table that has the details how the network should go to the next level, guys. It's our responsibility to set up this routing table and give it to your servers, then your server just follow the table, nothing else. Now my statement: whenever you are expecting a servers to be communicated with which are in two different networks, it is mandatory to have a routing table. Without a routing table, the communications will not be possible. If you don't have a routing table like this, now tell me guys, do you think the H machine can connect with E? Though you put a gateway, though you put a cable, still it will not work. The H will complain that, hey, the E machine is in different network. I don't know how to reach there. Can you supply me a route table? Without a route table, the servers cannot be connected, though you put a proper connectivity, network cable, everything you set up, no, it will not work. The routing table is mandatory. The routing table should have the routing entry or routing rule, the rule should say that the traffic should go in which gateway it has to reach to the destination. Good with this? And yes, the routing table should be there at each gateway also. That's for our understanding purpose. When it comes to the reality in the practicality, right, we will never worry about the gateway level routing tables. We only worry about our server level. The gateway level routing table is something that will be handled by the networking team, networking administrators. That is not our responsibility. So we don't need to worry, but yes, from the concept wise, yes, every gateway also will have their own rule setup. Are we good with this? Now maybe I have two more questions for you to wrap up this conversation, right? After having this information, right, now tell me from the data that you have in the screen, do you think the H machine can connect with E? Okay, if yes, do you think the E machine can connect with H? Okay, no. And again, my question, right? Do you think the H machine can connect with E? Right? The H machine can communicate with E machine? The answer is no. Why? The H machine may connect to E by sending the data. That is true because H machine know from the route table it can give to 2.1 and somehow the data may go to E machine, but E machine doesn't know how to reply back, correct? When E machine is trying to give the response back to the H, E machine understands that okay, the H is in different network. I don't have a route table with me. How to go with this, correct? What I'm trying to say here is having a route table in a source side is not enough, guys, because to get a response from the other server also should know how to give the response back. So the route table must be updated in both cases. And you see here in the E machine side as well, I'm maintaining a route table and I'm giving this route table to the E machine saying that if you see the destination is in 192.168.0.0/16 CIDR, then your traffic should go through 1.1 gateway. That's how I represented a routing entry here. In my case, the E machine IP 1.10, H machine IP 2.20, both are belonging into the data center CIDR 192.168.0.0/16, correct? So yes, I'm keeping the destination same in both places because both are belonging into the broader network. So you should be having the route table attached in both levels, then only it should work. It is okay to have the route table like this also if you want. You see here 192.168.2.0/24. If that is the destination, you use this 1.1 gateway. You can also do this also. Not worry, it will work. Either you use 2.0/24 or you use this broader network, either the case, because your IP is falling into or like it is falling into both networks, right? This is just a subnet. So in both scenarios, it should work. Now the last question for you. Do you think the H machine can connect with the client whoever is outside of the data center? After knowing this route table stuff? No, right? Because the H machine will look into the route table. Route table is not talking about the client in the outside of the data center. Hey, I don't know how to reach that. As of now, I know if the IP belonging into 192.168.0.0/16, then I know the gateway. But the client who is outside of the data center, I don't know how to reach because the route table is not mentioned accordingly. So I can't keep the client machine public IP in the route table, guys, because the client machine public IP will be keep changing. I don't know which IP that the clients will be using in, correct? That's the reason in your route table, you can update a entry saying that the destination is all zeros, then you please follow the 2.2 gateway. What does it mean by having the destination as all zeros? Wherever you see all zeros, that is called as a default gateway entry. That means if at all you are not able to find the proper destination matching, then you please follow this default entry and deliver the packet to that gateway. That is the meaning, guys. Because if I need to control my head server to be communicated with the internet, I can't keep the IP address in my destination section because I don't know in internet my client is using which IP. You got me what I'm trying to, right? So the client IPs will be keep changing sometimes. So whenever you don't know, right, who will be accessing my server from the public internet space, then you make that as all zeros. Then it thinks that, okay, I'm trying to connect it to a server from outside of the data center. That IP is not matching to any of the destination, right? Okay, then let me use the default gateway. So the traffic will go to 2.2 gateway as per this default gateway entry. That takes care of routing the traffic to the internet, and it will go to the next level. Hence the reason the gateway that is actually routing the traffic from data center to the internet, that is called as a internet gateway. The gateway that is actually responsible to route the traffic within the data center between the servers, that is called as a local gateway. With this, I'm done for today, right? So I have explained what is internet gateway, what is local gateway. Local gateways are used to provide a communication within the data center space or within the local networks level. The internet gateway is used to route the traffic to the internet space. That's how it works. The local gateways will be working with the private IP ranges. The internet gateway will be working at a public IP range. Being said that, now my last statement is the head server, whatever you see, right? The head server is called as a public server as the server is accessible from the public internet, which has a public IP. The E server, can I call the E server as a private server, guys? Why? The E server does not have a public IP. E server is not connected to internet gateway. E server is not accessible from the public internet directly, correct? The client from India, this guy can only access the H machine, right? The client cannot access the E machine directly. Why? The E machine is having only the private IP, which is accessible within the data center, which is not connected to internet gateway also. So H is the public server, E is the private server. The subnet that I have used for the H machine, that subnet I am calling it as a public subnet. The subnet that I have used for my E machine 1.0 is called as a private subnet. So in this context, 192.168.2.0/24, I am calling it as a public subnet as this subnet server is connected to the internet gateways, and 192.168.1.0/24 is called as a private subnet, whereas it is not connected to the internet gateway, right? And it is not reachable to the public internet space as well. So the private subnet server is more secured because the people cannot access the server directly from the internet. The public servers are less secured because it is accepting the data from the public internet space as well. That is the concept, guys. Now, how do we make this into implementation? Like, how do we give the route table? How do we attach the route table? Where do we see the route table? All this stuff we'll see in the tomorrow session. I hope you got the networking concepts a little simpler way. It's a little tricky to understand sometimes, right? And yes, the the required notes are given in our portal. I'll keep the link in our course tracker as well for your reference. And I will be transforming all these today concepts in practical tomorrow along with our AWS. Thank you. Thank you guys. If any questions, do let me know, or else I think we are good for today. Yes, in this context, if the e-machine cannot access the server who is coming from the public internet space, even via the H machine, no. E-machine cannot have the e-machine cannot access it from the public internet directly. I think maybe let me re-emphasize the statement again, because accessing the data is different, accessing the server is different, right? Maybe let me re-emphasize like this. In this context, the client who is in the public internet space, yes, this client can access the e-machine via the H machine. Yes, that statement is true. The client can go to the H, from the H it can go to e-machine. That's possible, not directly to the e-machine. That's true. That's true. Well, team, if any questions, do let me know, or else we are good for today. And we just need all these network definitions. That is good enough to get started with practical in tomorrow in AWS.
Pierre, please, how can I talk to you privately? I need an advice from you on something.
Hey, Mike, you know my WhatsApp number, right? You can always text me there.
Okay. I actually want to buy a laptop, so I'm wondering if I should go for Mac or Windows. So I need to.
Okay, I don't know if I can answer for that. Okay, so let me stop recording for now.